Welcome to the lab at Glasgow Science Centre. My name is Alicia, and we are going to be talking about my favorite part of Christmas, the stockings. Do you hang stockings up for Christmas? Maybe on the fireplace or at the end of your bed? What do you hope Santa will put in it? The tradition of putting stockings up at Christmas time comes from a really old story about St. Nicholas. That's Santa Claus. So the story goes like this. St. Nicholas, as we know, is a very rich and very generous man, and he loves helping people who need it. One day in town, he hears about a poor family, a father and his 3 daughters. Now, even though the family is really poor, the father is too proud to accept any help from anyone. And St. Nicholas wants to help, but this means he has to do it in secret. So, in the middle of the night, he travels to their house, and through an open window, he throws 3 bags of gold, 1 for each daughter. And one of those bags accidentally lands in a stocking that's hanging up to dry on the fireplace. And in the morning, the 3 girls wake up, and they find the bags of gold, and they are overjoyed. So today, we hang up stockings at Christmas time in hopes that Santa Claus will come and fill them with gifts and toys, just like he did for the 3 little girls that night. Come on, let's see what I got. Ooh. What's this? Oh, that's so cute. He's gonna go right there. Oh my gosh. An orange. Do you get an orange in your stocking? Now the orange is actually a symbol of the gold that St. Nicholas left for the 3 girls in the story. I love getting the orange because it is my favorite fruit. Not only does it taste delicious, but it also comes in handy segments so you can share it with your friends and family. But what's more? You can do some really cool science with an orange. Ready? Does an orange float or sink in water? Let's investigate this together. For this experiment, all you need is a large container full of water and 2 oranges. Now, if you don't have a large container like mine, that's okay. You can use a basin, a sink, or you know what, even your bathtub. So first, let's see if an orange floats or sinks. What do you think is going to happen? All right, ready? Oh, hey, it's floating. So when an object floats in water, we say that it is less dense than the water. Now, density is a word that we use to describe how much space an object takes up in relation to how much matter or stuff is inside of it. If an object is compact and heavy, we say it has more density. And if an object is light and spread out, we say it has less density. So let's try this experiment again, but this time we're going to take the peel off the orange. All right, now the orange is lighter. What do you think is going to happen? Oh my gosh, it sank. Wait a minute, why does the heavier orange float and the lighter orange sink? Let's take a look. The orange with the peel floats because the peel is porous and filled with all of these tiny air pockets. Now these air pockets make the orange less dense than the water, which causes it to float. When you take the peel off, you do make the orange lighter, but you're removing all of these tiny air pockets. That makes the orange much more dense, and it ends up sinking. Let's try another orange experiment. Oh, that's better. All right, so now we know what happens when we put an orange in water. What would happen if we tried to set one on fire? Let's take a look. Anything? No. Okay, so I guess it's not flammable. Orange peels have lots of tiny compartments that are full of oily liquids. Now, when you press on the orange peel, the outside skin stretches and those compartments get squeezed really tightly and it builds up a lot of pressure. Now, eventually, that pressure is going to be so great that those compartments are going to burst open and spray out this really flammable mist. Now, these oils are called hydrocarbons, and they're a bit like petrol, and they are also really flammable. When that flammable mist mixes with the oxygen in the air and hits that flame, we get a really cool fireball. I think we should try it again. Ready? 3, 2,
1.
So why do oranges have a really flammable skin? So oranges are a fruit, and they are designed to be delicious, and that means big animals will want to eat them. After the animals eat them, they'll move on to another location and eventually poop out any undigested orange seeds in a perfect glob of fertilizer. And those orange seeds are going to turn into an entirely new orange tree. Now, the orange really wants to be eaten by animals, but it doesn't want to be eaten by fungi or insects. The oils in the skin make the orange waterproof, and that means it's really hard for fungi to grow on it. The oils also act as a really good insect repellent. Now, I don't recommend you do this flammable experiment at home, but I do have one more orange trick that you can try. So we talked about hydrocarbons in the peel of an orange, and one of those chemicals is a very special one called limonene. Now, limonene is what gives an orange its very distinctive smell. But not only is limonene flammable, it has other explosive properties. Limonene dissolves rubber, which is what a balloon is made of. The limonene weakens the surface of the balloon, causing it to burst. Now, another cool thing you can try is putting this limonene all over your fingertip and touching the surface of the balloon, and you can cause it to pop. Ready?